Question number 30. Okay. Now it says X shows the position of a spectral line in the emission spectrum of helium from a stationary source. This is your from a stationary source. Okay. In a laboratory on Earth, right? The emission spectrum of helium from a star moving towards Earth is also observed. There is a star which is moving towards the Earth. So that is also has helium gas, and you are getting some emission spectrum from there. The speed of the star related to the Earth is 0.1. Okay. So this is your velocity of the star. What is the observed position of this spectral line in the emission spectrum of the helium? Now what's happening here? This is nothing but Doppler effect. Okay, so you have a star, and this star, what's happening? You observe the star is moving towards the Earth. This is the Earth. This is the Earth. And something is moving nearby to it. What will happen? The more number of frequency will increase. The frequency will increase over here. When frequency increases, this will not be equal to f, but it will be f dash. When frequency increases, the wavelength should decrease. Wavelength should decrease, right? The wavelength should decrease. This means definitely, okay, initially the actual wavelength of this line Yx was seen to be, let us say 600. This is 500. This could be 550. This could be 580. Let me assume. Okay, this is 580 over here. This was the actual one. Okay, when it is moving nearby to it, frequency increases. As a result of it, the wavelength should decrease. So definitely C and D are incorrect. It should be BRA, but we still need to find out, okay, whether it is BRA. So how do I do that? So towards it, we know what is the expression for Doppler effect. Expression for Doppler effect is delta F by F is equal to V by C, right? So delta F is change in frequency, by F here is equal to so much. V is equal to what? 0.1 C. I put this 0.1 C by C, which should be equal to 0.1. So delta F is equal to 0.1 times F. What was the frequency we took? We took frequency 580 over here, right? We took 580 over here. So thus we'll get 0.1 into 580 would be 58 Hertz. Change in frequency would be 58 Hertz. If that is the case, the change in wavelength will also be closer to it. Okay. If this is what it is, then change in wavelength should also be closer. So it cannot be very farther away here. Therefore, B should be right, right?